Okay, this is video 4 for C1. So we're going to look at is extracting metals. Okay, so where we're going to extract metals is from ores, and ores are defined as rocks that contain enough metals to make it economical to extract the metal. If there's not enough in there, then if we spend all this money trying to extract it, we're never going to get our money back. So it's not classed as an ore if there's not enough metal present. So there has to be enough metal to make it economical to extract the metal in the first place. That means you get your money back from the metal when you get it out of the rock. And ores are mined normally, so dug up from underground in the rocks, and they can often be concentrated before you then extract the metal, so you can get more of it before you then start extracting the metal. Now, the really important thing with extracting metals is you need to use the reactivity series. Now, you'll be familiar with this document, the periodic table, from your exam papers. If you're doing past exam papers already and you've seen these in the classroom, this is the periodic table of elements. On the back of that is some really useful information, the reactivity series, and this is what you need to use when looking at many things, but in particular when you're looking at extracting metals, okay? Because this tells us what we need to use to extract the metal depending on if it's very reactive or if it's not very reactive. So this data sheet is really important, okay? So if we look at the reactivity series, we can see there's a couple of words here that are important. So carbon and hydrogen. I've highlighted them here in red. On your data sheet, you'll see it's in italics. So it's slightly slanted in terms of the text. So you can see that it is slightly different. So for metals that are very reactive, so more reactive than carbon, we need to use electricity. So we need to use a process called electrolysis to extract carbon from the metal. So we might see that we've got magnesium oxide, and then what we do is we use electricity in a process called electrolysis, and we can remove the magnesium away from the oxide, okay, so we can have it on its own. This is good because it's really useful, but it uses large amounts of energy because it's electricity, so it does make those metals really expensive. So these metals here are going to be quite expensive in terms of buying them, or anything that contains those metals, that's going to be very expensive. For metals that are less reactive than carbon, what we can do is we can extract them using carbon. So if we look at an example here with iron, we've got iron oxide, so that's the ore there, that's the ore, plus carbon, so we'll react it with carbon. Now if we look at iron in the reactivity series is underneath carbon. So if I react it with carbon, carbon is more reactive, so it will steal that oxygen away from iron. So we've now got carbon dioxide and we've left iron all on its own. So if the metal is anywhere down here underneath carbon, we use carbon, which is cheaper option, so the metals remain cheaper. But if it's above carbon, these are more reactive, so reacting it with carbon won't work, so we need to use electricity. Okay, so we call it reduction with carbon if it's a metal underneath carbon in the reactivity series. So if you use your data sheet, you can work out which ones are underneath carbon, therefore we'd use carbon to extract these metals. If, however, they're right at the bottom, like gold, okay, it's very unreactive, so it's probably found just on its own in the earth because it won't even react with oxygen to form an oxide because it's so unreactive. Okay, there's a couple of examples that you need to know in particular for extracting metals, and the main one is copper. Okay, so copper can be extracted from its ore by smelting, which is just burning, but depending on if it's rich or low grade, so lots of copper or not a lot of copper, we have two different things. So smelting is when it's really copper rich, there's lots of copper in the ore, and then we purify it even further using electrolysis, so using electricity. With copper rich ores though, they are depleted, which means we don't have very many of them. So it means the extraction has environmental impacts. So we're digging deeper into the ground, we're digging wider, etc. So it does have environmental impacts. There are some negatives with these copper rich ores. Low grade ores, so ores that don't contain very much copper, we're not going to do this process because electrolysis is really expensive because it requires lots of energy, and if I don't get much copper out of it because it's low grade, then there's no point in using electrolysis. So I'm going to use plants or bacteria, which are far cheaper. So if I use plants, it's called phytomining, and if I use bacteria, it's called bioleaching. Okay, and all that means is with the plants, we have a mound of copper, we plant the plant, We let it grow in, it takes up copper out of the soil or out of the mound that it's growing on. We then burn that plant, and then we have copper in the ash. And with bacteria, it's placed on the copper slurry, what's left over from industry, from a factory, and the bacteria will then excrete or produce copper for us as a product, as a waste product, so we can use that. Okay, so that's it. Cheaper options if the copper is low grade ore. Right, aluminium, titanium are also mentioned in your specifications. So aluminium and titanium cannot be extracted with carbon. So the problem is they have lots of stages, many stages. If you look here, aluminium is above carbon, so it has loads of stages, and we need large amounts of energy, which makes them negative. So they're going to cost a lot more. So it may say, why is aluminium or titanium expensive? It's expensive because its extraction has many stages and it uses a large amount of energy. Okay. It's really important overall that we recycle metals in general, because we have a limited amount of resources on Earth which we're using. Okay, they're expensive and they have big impacts on the environment, so we have to dig down into the rock. So all of these reasons is why it's important to recycle. So if you get a question on recycling, make sure you have a specific answer. So we've talked about the definition of ores, what they are, the fact they're mined, checking that reactivity series. If they're more reactive than carbon, we have to use electricity to get rid of them and get them out of the rock. And if they're less reactive than carbon, we can react them with carbon. Carbon being more reactive will steal the oxygen away, leave the metal on its own for the manufacturer. We've talked about copper rich ores, removing it with smelting, copper low grade ores, using plants and bacteria, so phytomining and bioleaching. Try and remember those two terms. We've talked about aluminium and titanium being difficult to extract, lots of stages, large amounts of energy, so they're expensive, and then why we need to recycle. Okay, so that's the end of part 4 for C1.